This is Katie Bowman's AP problem number 12. Let's start by reading the question. Part A asks, consider the carbon dioxide molecule CO2 and the carbonate ion CO3 2 minus. It asks to draw the complete Lewis electron dot structure for each species. So for CO2, it's going to be a linear structure with C in the middle and then 2 oxygens on each side with double bonds on both sides. Carbon wants 4 new electrons and oxygen needs 2 each to complete the octet rule. And then CO3 2 minus is going to look like this. C's in the middle, 3 O's all the way around. One of them is going to have a double bond. You can change it and put it wherever you want, but it has to have 1 double bond in there. C in this case also still needs 4 electrons, and the oxygens need 2, but there's 3 of them now. And then part 2 asks, account for the fact that the carbon-oxygen bond length in CO3 2 minus is greater than the carbon-oxygen bond length in CO2. So the double bond length in CO2 is shorter than the single bond, but the CO2 minus is all about the same length, and it's greater than 1. So the double bond length in CO2, there's 2 sets of bonds, and when you divide it by 2, you're going to get 1. And then when you do the CO3 2 minus, you get about 1 1/3 when you divide it by 2, so it's a greater number. And then B asks, consider the molecules CF4 and SF4. Draw the complete Lewis electron dot structure for each molecule. So CF4, C carbon needs 4 more valence electrons, and F needs 1 each for each 4. So it's going to have 4 around each side. There's no more lone pairs with carbon. They're all matched up with a fluorine ion or a fluorine element. And then SF4, you have S in the middle, and then F bonded all the way around. But since S is in a 3rd orbital, it can match up with more, it can pair up with more elements than it necessarily would. It can break the octet rule. It also has 2 lone pairs, or 1 lone pair on the outside, which would make it a polar structure. So that relates back to the next question. In terms of molecular geometry, account for the fact that the CF4 molecule is nonpolar, whereas the SF4 molecule is polar. So CF4 is symmetrical and has no lone pairs, which makes it a tetrahedral, while SF4 is asymmetrical with 1 unbonded pair on S, which makes it seesaw. And seesaw is a polar geometrical shape, and then tetrahedral is a non-polar. Yeah, thanks.